we start talking about the force of gravity. And any two objects are attracted to each other by a gravitational force. Now, we're used to thinking that like the moon orbits the Earth because the Earth pulls on the moon with gravity. It's also true that the moon is pulling on the Earth with gravity. And it's true for any two objects. So for this example down here, we got a 50-kilogram student and a 70-kilogram student. We don't think about it, but they're attracted to each other by a force of gravity. We can use this equation to find the strength of the force of gravity. And the M stand for masses there. So we got two objects, mass 1, mass 2. The G is the gravitational constant. Which is 6.67 times 10 to the minus 11. Newton meters squared per kilogram squared is the unit squared. And R is the distance between the centers of the objects. So here's an example where we're going to use that. Find the force of gravity between the 50-kilogram student and the 70-kilogram student who are 2 meters apart. So we'll plug in this equation. G is always the same constant, 6.67 times 10 to the minus 11. One of the masses is 50, 70. We're going to divide it by the distance between them, which is 2 squared. When we do that, we'll get a value of 5.84 times 10 to the minus 8 newtons. Now, that is a tiny force. We're going to find the excess, so I'll draw this. So I have the 50 kilogram force for the 5.84 times 10 to the minus 8 current, and the 70 kilogram force. That's the same force pulling him the other way. They're equal opposite forces. Then to find their acceleration, I do have net equals A. So 5.84 times 10 to the minus 8 is 50A. So the acceleration for the 50 kilogram would be about 1.2 times 10 to the minus 9 meters per second squared, which is a tiny little acceleration. You don't have to write this, but if I was going to show it, it would be 1. That would be the acceleration, which is not something that you'd even measure. However, if these two people were floating around in space and there was no friction, nothing to keep them apart, they would slowly come together. It might take an awful long time, but eventually they would end up together. Now, here's an example to think about more often. We want the force of gravity between the Earth and the Moon. Okay, so we'll use the same equation. G is G over R squared. G is always the same, 6.67 times 10 to the minus 11. And by the way, you don't have to memorize that. It's on the front of the reference table. The mass of the Earth is 6 times 10 to the 24th. The mass of the Moon is 7.35 times 10 to the 22nd. I'm going to divide it by the distance between them, which is 3.84 times 10 to the 8. We got to remember the square. So then we'll get our answer. 1.99 times 10 to the 20. So that is the force of gravity between the Earth the moon. Now, this thing which experiences a bigger force, remember, if I was to do this kind of the other way and put the moon's mass in here and the Earth's mass here, I would still get the same value. They're the same force. They're equal and opposite. So they have the same force. They're equal and opposite. Okay? But the moon would have a bigger acceleration. This has a smaller mass. And that's why the moon orbiting the Earth and not the way around. Now, another way they could ask them is like this. Force between Jupiter and one of the moons. F, what would it be if, or A, if distance doubled? So, R doubles, what happens to force of gravity? Okay? So, what I do is I take a look at the equation. You can see this as G is G over R squared. The only thing I'm changing is this R. Okay? So if I double it, I would have a 2 squared on the bottom, which would be 1/4 as large. So it would be F divided by 4. For B, we're going to have the mass double. And our triples. And I want to know what's going to happen. I just look at the equation again. You're changing one of the masses, doubling it, and tripling the R. So that would be 2 on top because I'm doubling one of the masses. And I'm tripling the radius. So I got to remember to square that. So it's going to give me 2 over 9 times large. So that means 2 out of 9.